A really good way to show that the change in velocity or the acceleration when you're dealing with circular motion is to show that that is towards the center of the circle is by approaching it in the following way. If we look at something moving around a circle and it's in two separate positions after a period of time, you look at the initial velocity and we look at the final velocity, and if we do a vector calculation to find the change in velocity, which is the final minus the initial, which is also the final plus the negative of the initial. When we find the change in velocity, that'll show us the direction that the acceleration is, because the direction of the acceleration is the same as the direction of the change in velocity, which makes sense because your velocity is a vector quantity which has both magnitude and direction, so the change direction is important. Anyway, continuing on with this, let's just make our marker slightly smaller and change colour. The change in a vector quantity is the final plus the negative of the initial. Here's the final. That's the initial up there. I've made that a pretty poor vector, but the final is downwards, and the negative of the initial is in that direction, because it's just in the opposite direction to there, adding vectors top to tail. So that's the final, that's the negative of the initial, and our change in velocity between position 1 and 2 is therefore in that direction. And if we map that onto our diagram here, we can see that the change in velocity is indeed towards the center. You see how that matches up over here at the same vertical angle. Yeah, final thing, change in velocity over change in time is the acceleration, and that's where the link is. That's the formula. Okay, a little bit back to front, but hopefully you get the idea. You can try that on your own to test it out.